So for the next panel, we will have Benoit Sagot and François Yvon. They are both researchers in NLP, and they will talk about GPT-3. So Benoit Sagot is Research Director at INRIA, head of the Almanac team, and holder of a PRAIRIE chair. He is co-founder of two INRIA startups, Verbatim Analysis and OpenSquare. François Yvon is a Research Director at CNRS. He is a member and former director of the LIMSI CNRS laboratory in Saclay. So I give you the floor to introduce the subject. Maybe François?
Yes, I will start with trying to explain very briefly what GPT-3 is. So GPT-3 is what we call a language model. That is, in essence, a system that you can query for computing the probability of a sentence, of a linguistic utterance. And more generally, you can also query a longer piece of text. In this family of models, GPT-3 belongs to models for which a sentence is just a sequence of words, one word after the other, and you predict the probability of a sequence by predicting the probability of each word conditioned on the previous words. And an interesting property of these models is that you can also use them to generate new text. It's just a matter of sampling a new word given the previous ones. So these systems have been around for many, many years. I mean, they date back to the beginning of the 20th century and have been introduced by the Russian mathematician Markov. And they've been around also in NLP for quite a while because they were used for spelling error correction or for automatic speech recognition. And the main difference with today's system is that former systems were using a very, very short context. That means they were using only one or two or maybe three previous words to predict the next word. With the advent of neural models, and they were introduced by Joshua Bengio and his team in around 2000, we were now in a position to use a much larger context through projection into a continuous space, meaning that we no longer have to just look at a couple of words, but we can look at maybe 10, 15, and then maybe now more words. So this is one major difference, and these neural systems have been used in machine translation and also speech recognition successfully for nearly 20 years. But with GPT-2 and now GPT-3, the situation is even more changing. So maybe Benoit will explain why.
Well, yes, just in a few words, I think it's interesting to understand that the GPT family of models is one of the two main families of language models that have been developed in the recent years. In fact, on the one hand, you have the so-called masked language models, which learn to predict a word that has been hidden or masked out in a sentence. And you have this other family called generative language models, for which GPT-1, GPT-2, GPT-3 are interesting examples. And as François just said, GPT models are trained to predict the next word when they are provided with the beginning of a sentence or the beginning of a text. Whereas masked language models are trained to guess a word that has been masked in an input sentence. And maybe the most famous of this class of model is the Bert model, published by Google in 2018-19 for English. And since then, a lot of different models inspired by Bert or derived from Bert, including Camembert for French that we produced, have been published. And this is one class of models that are usually used not for what they are trained to do, that is guessing a word that has been masked in a sentence, but for the vector representations of words in context that they create. Whereas GPT-like models are usually used for what they are trained to do, which is to guess the next word. And then one after the other, you can actually produce a whole text. Now, why is GPT-3 somewhat new with respect to GPT-2? In fact, it is not new in terms of the neural architecture, but it is new in terms of how big it is, in terms of the number of parameters, and it is new in terms of how much text was used to train the model. Just to give you orders of magnitude, GPT-2 has 1.5 billion parameters, and GPT-3 has 175 billion parameters, which is more than 2 orders of magnitude more.
So thank you. You are talking about very large models. We have seen with Francis Bach and Chloe Azencott this morning that we can worry about ecological impact and so on. But what is the cost of training such networks, even in a computer scientist point of view? Who can today have in-house data, in-house computation power to train them? Is it really research, or is it just a question of who has more of everything?
Well, first of all, I'd like to state again that it is an impressive achievement to be able to train such a huge and high-performing model with the number of parameters I just mentioned. But again, at the same time, GPT-3 is only an incremental improvement on GPT-2 in terms of the neural architecture, so it is not really a scientific breakthrough. I don't really think it's just a question of who has the biggest model. It's more a question of what is going on when you train a larger model on more data and understanding what are the consequences of this increase in number of parameters and size of the training data. And in fact, GPT-3 exhibits properties that GPT-2 did not exhibit. And this is probably more because of the increased model size than because of the larger training data. And interestingly, it seems that the ratio between how much better such models perform and how much computing power is necessary to train them is decreasing. Now, to come back to your first question, yes, the computing power necessary to train GPT-3 is only available to a small number of organizations, but the situation will probably be different in 1 or 2 years. Still, it's true that training GPT-3 is a challenge today, and that raises both engineering questions and scientific questions. I think we'll come back to the latter a little bit later. And it does raise questions in terms of the energy consumption and the ecological impact of training such a model. And obviously, when you train such a model, you train many, many models before you train the final model. So that demultiplicates the impact. And I think there is a growing awareness within the AI community and the NLP community in particular that the carbon footprint of AI is increasing in a somewhat problematic way. And this has triggered the emergence of research directions such as sustainable AI or green AI. Now, another limitation is training data. I believe that the amount of training data used to train GPT-3 is around 500 million words, which is not something that is available for many other languages apart from English. So this is a limitation, but it also opens scientific questions which are directly related to the challenges of sustainable AI. So I think there is something consistent here.
François, do you want to add something?
Yes, I mean, as Benoit said, I mean, as it's the first time we do things at such large scale, it's only possible to do it if you have very large computing infrastructure and very few organizations. In that case, it was Microsoft cloud computing infrastructure that was used to train the systems. Now it's clear that maybe in 1 or 2 years from now, we'll be in a position to reproduce these results and to deploy them, because in the meanwhile, we are going to develop new algorithms, new tricks to train these large systems more efficiently and with less energy consumption. So what I would like to add maybe is the fact that this kind of research where you try to build very, very large systems is only relevant for a subpart of the field. I mean, because as you grow in size, you tend to abstract away from the very fine-grained characteristics of your text or of your language. And in fact, I mean, as GPT-3 is so huge, it can process any language. But at the same time, that means that it doesn't have even the notion of a word. It just processes character strings, and this is a common denominator of everything it processes. It can process codes, it can process English and also French and also many other languages and also numbers. But the the price to pay for this generality is that it has absolutely no notion of linguistics, and it doesn't even know what a word is, in fact.
But thank you. But then, who can guarantee the quality of the results? Who can? Is it really useful, or is it just a demonstration of feasibility?
Well, maybe I can start. I mean, these are, as we said, the stochastic system. So they have, in essence, a stochastic behavior. That is, they are very good at reproducing what they have been trained for. So if, I mean, they won't make hardly any errors in very common linguistic context, like they can very easily predict the object of a common verb. But as soon as they are provided or fed with unexpected inputs, I mean, that can be for many reasons. You can imagine of feeding them with unexpected input. Then the answer can be unpredictable, and that's I guess it's very well explained in the GPT-3 paper, where they try to test it with systematic tasks where you would expect rule-based behavior, like counting, for instance, where the output is deterministic, or other language-related tasks. And it's clear that the system has still a stochastic behavior. That is, most of the time it can count well, but sometimes it makes errors and nobody knows why, and they are unpredictable. So if you want to use these things for a task for which you need to have a guarantee on the output, they are not the proper way to do things.
Benoit, you want to add something?
I think your question was really important. I think the problem of how and whether we can have guarantees on the quality of what GPT-3 produces is the real issue, not for the model itself, which works as it is designed to work, but for its usability in real-world business scenarios, for instance. So, as François said, today there is absolutely no way to guarantee that the text produced by GPT-3 will not contain errors and biases, and that it will exhibit all the properties that we would like it to exhibit. So you have the problem of errors and the problem of like an error as in producing the incorrect answer to a meaningful question. And then you have the problem of producing an answer to a meaningless question that should not have received an answer because it is meaningless. For instance, and this is something François mentioned as well, a question such as who was the president of the United States in year 1455? Probably GPT-3 would produce an answer to that question, and the question is absolutely meaningless. But then on top of the problem of errors, you have the problem of biases that are in the text on which GPT-3 was trained, and which therefore will also be found in the text that is generated by GPT-3. And for instance, the authors of the paper tried prompts such as "he was very blank" or "she was very blank," and they analyzed which follow-ups to "he was very" or "she was very" GPT-3 would produce. And they found out that after "she was very," you had things that were more related to their appearance, beautiful, gorgeous, petite, and so on, that were most probable, most likely. Whereas after "he was very," it was more varied, such as adjectives such as personable, large, lazy. And of course, this is not an intrinsic property of the GPT-3 architecture. It is a property of the text on which GPT-3 is trained, a property that is obviously found again in what it produces. And I think that that's also something problematic, but it's also, as always, when something is problematic in science, it raises interesting scientific questions and challenges. So yes, this is, I think, one of the important scientific challenges that we have to deal with models such as GPT-3.
Yeah, so oh, sorry.
Yeah, just to be complete, I mean, I wanted to try also to answer the question that Benoit raised about how can we use these models, these unpredictable models. And I think one obvious answer is we can use them to do what we used to do with language models, and these are extraordinarily powerful language models, so we can still use them to do spelling correction or to do automatic speech recognition. And there is also the risk of malicious uses of these models, because they can generate text that is often very fluent and looks like a natural text. So they can be used to generate content for to publish on Twitter, to publish on fake websites, etc. So there is a clear ways in which you can use these models for malicious purposes. It's less clear how you could use them also for less malicious purposes.
Well, maybe I can provide you with an example of that, because there is one very specific example of a real-world use case for GPT-2, which could obviously be improved with GPT-3. And that is the following one. The team who built the system used by Stephen Hawking to communicate is now involved in the development and improvement of a better system used by someone called Peter Scott Morgan, who is a British roboticist who suffers from the same condition as Stephen Hawking. And being able to communicate is obviously very important to Scott Morgan, as it was to Hawking. But Hawking felt that having the full control over what he was saying through the system was more important at the cost of speed, whereas Scott Morgan strives to regain the speed and spontaneity of communication that he used to have, even if it implies losing some control. And of course, achieving this requires to predict as well as possible what Scott Morgan, for that matter, could wish to say at any time during a conversation. And in fact, to do that, the team at Intel who used to work with Hawking are now using GPT-2, and they actually have trained GPT-2 on a corpus of Scott Morgan's speech and writing, which of course raises the question of the balance between how close to what he wanted to say GPT-2 suggestions are versus how fast he wants to be able to answer a question or to talk in a conversation. But to improve the system more and more, they have incorporated several ways for Scott Morgan to provide feedback and so on and so forth. So you see that sometimes, and maybe it's a very specific case, but sometimes these generative language models can be used for what they are, generative language models, in very positive and beneficial circumstances. So that also exists.
So thank you. Maybe a last question. So we have seen that there are still some scientific challenges. We are happy for you. We have seen that GPT-3 is a success, but is it a scientific success or an engineering success? Does it open scientific question? And maybe a very last question. Is it a problem for you, researcher in the same domain, to be a face of this sort of a big system that we cannot have in public research?
Maybe I'll start. Yes, I mean, it's as Benoit said, an impressive engineering challenge to train such models. And but I think the science is just starting now. I mean, these models have been around, as we said, for a couple of years now. And we're still trying to understand how, for instance, learning is possible in such large spaces. I mean, learning shouldn't be possible, generation should not be possible, but still the system generalize, abstract. They abstract from the text some properties of English, and it's interesting to see which properties of English they can abstract, which they cannot abstract. That's also interesting. Another area where we expect scientific improvements is, as Benoit said, we have known for a long while that texts in general that contain knowledge, but they also contain bias regarding the society, and they just contain the knowledge about the society in which they were written. So in the past, we were only able to analyze this bias through statistics, but now we can also analyze this bias through manipulations because we have a system that is trained to replicate this bias. So we can probe these systems to exactly dig this bias and expose them, and then see how we can also remove them from the system. So all this is interesting. I could mention another area where GPT-3 OpenU Alice is really the way it can do learning without learning, meaning it's so large that you can prime it, as it were, to exhibit some specific behavior without any learning. And that's really novel, that's really interesting, and we have to see how to better exploit this kind of ability to do very few, to drive the system into a behavior that he has not explicitly been trained to perform, like for instance counting, like for instance doing language manipulation, but also answering questions, even though it has never been trained to answer questions, or perform machine translation, even though it has never been explicitly trained to do machine translation. So understanding why this system can exhibit this behavior that they have never been trained for, that's also an interesting scientific challenge.
Thank you. Just a few last word from Benoit.
Yes, I think François basically said it all. I think something very important will be when we will see new types of models that behave pretty much in the same way as GPT-3, but that will require fewer parameters, less training data, a little bit as we have seen in the past, some sort of an alternance between high complexity, high size neural architectures that improve the state of the art, and then efforts to significantly decrease the complexity and cost of such architectures without losing too much on the performance side. So for instance, you can think of LSTMs, then GRUs, or BERT, then Roberta. So I suspect we will see sort of GPT-3-like systems, models, architectures that will require less computing power, less training data. And that might open the way for such very large, high-performing models for other languages, multilingual GPT-3-like models as well, and so on and so forth. That will certainly open even more scientific research questions on top of all those mentioned by François.
Thank you very much. Thank you, François. Thank you, Benoit.